As you probably noticed, Mr. H is not in today. That's because I have some meetings that I have to attend. I will try my best to get into the classroom during the day just to check up on how things are going. For right now, though, with the video, I'll tell you exactly what we're going to be doing today and what you need to try to accomplish. We'll start off, as always, with our do now. Make sure as well you're writing down your home learning. And the home learning is that you will, if you didn't do as well as you had hoped on the water temperature summative, there is going to be a retake opportunity on Wednesday after school. So if you want to attend that, that's when it will be. Looking at the do now, you can pause the video and fill out the do now questions, and we'll come back to the answers momentarily. But for right now, pause it and let's try to answer those 3 questions. All right, now that we've had an opportunity to write down the do nows, we'll get into the actual question. It says, how does the angle of the hang glider affect how quickly Mr. H is able to descend? The independent variable would be the angle of the hang glider. The dependent variable would have to be how quickly I descend, and then some 3 different controls. Could be like the wind speed, or the person that's hang gliding, or the same hang glider, or the same location. Lots of different options there. As far as today goes, we don't have any new know-its or vocab. Starting off as always, 3 something cools. This is the world's tiniest lizard. It's something called a pygmy gecko. Really, really tiny. The fun part is that this is an adult, and the babies are way smaller, about the size of their head. So just tiny, tiny little lizards. Second something cool. By the time you're done reading this sentence, about 50 million of your body's cells will have died and been replaced. Mostly skin cells and blood cells, but 50 million died, 50 million, 50 million, 50 million. It's crazy. Third something cool. Just as human infants like to suck their thumb or suckle their thumb to calm themselves, elephants actually do the same thing, but they use their trunk instead. So baby elephants will actually suck on their trunk to calm themselves down. It's kind of a cute little thing about them. But anyway, those are the 3 something cools. All right, moving on to what we have to do today. Today we're actually starting a project which is basically going to be continuing throughout the entire year. Each unit that we go through, there's going to be a mini project that we're going to do. And when I say mini, it's actually quite large, but each unit will have its own project that will ultimately culminate throughout the entire year by adding more and more to it. So today we're starting off with the chemistry portion of it, and that looks something like this. And so what we have is that for this chemistry unit, you're going to be creating a brand new alien compound. And when we get to ecology, you're going to be creating an organism, a new organism that uses that compound. And then geology is you're creating a planet where the organism lives. And astronomy, you're creating the solar system where this organism lives. Anyway, we can give you more information about that as we go along. But today, we are going to be starting that project with this new alien compound. And the way that it works is you're essentially a scientist, and you've been sent to explore a new galaxy called Rigpenton 3. And in your exploration, you've discovered 30 brand new elements that have never been seen before. And you have been asked to complete certain tasks using these elements to find out more about them and the galaxy as a whole. So you want to use these different elements down below. There are all sorts of weird ones that have been created, like Doggone It or Nuart. Terbium, any of those you're able to use to create your new compound. So there are a number of different tasks, and task 1 is you actually have to create a compound. It might be a good thing to go back to your chemistry outline to take a look if you need a little bit of a reminder as to what all of these different terms are, because it has been a while since we've done them, but you can still go through and look up that information again. So under task 1, there are quite a few little parts. The first is you got to select the atoms that you would like, or the different elements that you would like. Just highlight them. If you wanted to use Ernst, just highlight it, and that lets us know that that's what you want to use for your particular elements, or for your compound. So first and foremost, you need to tell us which elements you want to use, and then you need to tell us how many atoms of each type of element you're going to have in your compound as well. So there you just have to tell us, okay, I want 2 Oz atoms, 1 extracon, and 1 chow. So you just tell us how many of each of them. Then you got to come up with a name for your compound, and it can either be a scientific name, like you could say dihydrogen monoxide. That would be a great scientific name. It's telling you the number of atoms and the type of atoms. This is, of course, in our own solar system. Or it could be just a common name. If you wanted to call it something else, like water is technically a common name for dihydrogen monoxide. So if you wanted to write a scientific name, go for it. If you wanted to have it be a more common name that everybody else is going to be able to pronounce, feel free to do it. You do need to be able to pronounce your compound's name, however. So if you just kind of went like, yeah, that's my compound, you have to be able to say that out loud. The next part is that you've got to create a model of your compound, and not just one model of your compound. You have to create a model of 3 particles of the compound. And the best way I could describe it is the following. So you could draw this on paper if you wanted, or if you'd like to do a Google Draw instead, you could do it that way. So essentially, if you were drawing your compound, and Mr. H will just use 2 different atoms very quickly just to show my compound. Let's pretend that this one is red. Awesome. There's my compound. The reason I want to have 3 of them is because part of, oops, I just messed it up. Let's see if I can do it again. There it goes. Da, 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 da. There's 2 particles of my compound. There are 3 particles of my compound. And the reason why I want to have 3 is because also on this model, you're going to be trying to describe as many, using as many different vocab words, the picture that you've drawn on there. So again, one way you might be able to do it, again, is using a text box. You could say like, this is called an atom. And you might be able to like use an arrow or something pointing at one of them, or you might draw a circle around more than one of them and say, okay, this whole thing right here, got to make it transparent. This whole thing right here is going to be considered a compound or a molecule. Or maybe you can expand your circle to include all of them in one place, and you might be able to say, oh yeah, this is a pure substance or a mixture, whatever it is. We just want to make sure that we have 3 particles of our compound in there. So that's what you have to do for that part 1. Again, make sure that you're describing or labeling the matter using words within the actual drawing itself. Second part to this one is you got to start telling us about properties of your compound. This is completely up to you, how you want this compound to behave. Tell us stuff like, okay, what is its state of matter? Is it going to be a solid when you find it? Is it metallic? Is it really hard? Does it conduct electricity? Is it blue? What temperature does it melt at? Think of all sorts of crazy components about this compound. The more detail you can come up with here, the better off you're going to be later on in the next projects. Because the more detail you're able to give about it, the easier it'll be to come up with some potential uses. So based on all of the properties that you came up with, you got to tell me some things that you might be able to use this compound for. And yes, a lot of kids like saying, okay, it explodes when it comes in contact with water. Fine. But what I don't want is, down for one of the uses, I don't want you just to simply say, okay, it explodes so we could use it as a weapon. I want you to think a little bit bigger than that. What are some different uses that either you or a new organism might be able to use it for? For example, if it's like really hard, you could say that the organism, this is in ecology now, you could say the organism uses it as like an armor to protect it from its predators, something like that. So get really creative with these 2 parts, the properties, because that's going to help out with what some uses would be for the compound itself, both for you and for potentially new organisms. So that's all step 1, or task 1. Task 2. You then have to create a model showing how your compound changes state. Basically, this is exactly the same as that one summative that we did with the vibranium, with the Black Panther. It's exactly the same. So it's asking what happens to the motion of the particles, the temperature, the spacing, and the thermal energy as energy is added and removed from the substance. So if you want to draw like 3 boxes for solid, liquid, and gas and kind of have arrows, go for it. Again, if you wanted to do this on paper, you can. If you wanted to do it just on the computer using Google Draw, inserting a drawing, go for it. That would work as well. Completely up to you. The more information that you can show me, the better. But keep in mind, a good model is basically going to be 80% pictures and only about 20% words. So keep that in mind. Final task then, after you've shown how it changes state, the next question that the scientists want you to answer is, okay, now that you have a good understanding about how the compound looks and how it behaves, now you got to tell us how you would set up the following experiment. And I think I missed something here. I should probably put another section down below before I forget. Oops, let's go right there. Boom. My apologies, this should have been done before. Procedure. Boom. And this is going to be numbers instead, but we got to restart the numbers. I can't restart the numbers. Why not? Why no restarting of the numbers? Yeah, well, we'll have to figure it out. These have to be bullet points. And these have to be numbers. Can I yeah, I did it. Cool. So, well, there, we'll just leave it. So what you're going to do is you're going to be figuring out a way to set up this particular experiment, trying to answer this question right here. Mr. H and the rest of the scientists want to know, how does increasing the mass of the compound that you have, so the more of this compound that you have, how does it affect the amount of energy needed to get it to change state? So if I add more compounds of our substance, how is it going to affect the energy? And you've got to identify the variables, independent, dependent controls. You got to write me the scientific question. Remember, just highlight one or the other. Don't leave both of them there. I need a hypothesis, and then finally we need a materials, and we need a procedure. Again, I just added the procedure down below, but I'd like the same thing. So how would we actually conduct this experiment? Give me the different steps. Notice there is no CER involved with this one, which is great. All right, last but not least, the final thing I need to point out is this. There are 3 standards that you're going to be graded on: your atomic modeling, you've got adding and removing energy, so talking about changes of state, and then as well the investigations. Those have been the 3 summatives that we have assessed so far in chemistry. So one was with atoms at the very beginning, one was with, sorry, there's the atoms, this one was with change of state, and then this one was conducting investigations. If you did poorly on any of those previous summatives, this is going to be the opportunity that you have to try to increase your score in those summatives. This is the last opportunity that you'll have to do that. So you want to make sure you do your best work. Don't worry so much about what the web page is all about. I'll talk about that next class period. For now, you can get started and work on this whole section, task 1, 2, and 3. To answer many of your questions, this project, because it's so large, we're actually going to work on it for about 3 full class periods. So you'll have 3 full class periods to work on it, and if you wanted to do any work outside of class on your own, you can do that as well. For now though, and the rest of the class period, you can get started on this document. If you have questions, send me an email and I'll try to get back to you throughout the course of the day, and I'll try to check in on you as well. We'll see how that ends up going. Good luck, and I hope you have some fun with this, and I will see you next class period.